Hello and welcome to G Fun Facts Online. Today we are heading to the rugged, windswept coastline of Casablanca. While this city is usually associated with the romance of the Atlantic or the bustle of Morocco's economic hub, we are looking much deeper today. We are looking beneath the modern streets and into the cliffs, where a geological archive has recently rewritten the opening chapters of the human story. We are talking about a groundbreaking discovery published in Nature in early 2026, where an international team of researchers identified hominin fossils from the Quarry site. These aren't just any old bones. They have been securely dated to 773,000 years ago, and they are changing everything we thought we knew about the origins of our ancestors. To understand why this is such a massive deal, we have to look at the timeline of human evolution. Paleoanthropologists have a name for the period between 800,000 and 400,000 years ago. They call it the Muddle in the middle. It is aptly named. This was a geologic epoch defined by absolute chaos. You had intense climatic instability, massive glacial cycles that were reshaping the entire globe, and complex hominin migrations, where populations were expanding and contracting across Africa and Eurasia. It was a biological crossroads. This was the time when the ancestors of modern humans, Neanderthals and Denisovans, were just beginning to diverge from one another. But for decades, scientists have been baffled by this era because of a frustrating scarcity of well-dated fossils. Think about the fossil record like a book. We have the beginning and we have the end. But the middle chapters have been torn out or stuck together. In Europe, we had sites like Atapuerca in Spain, yielding Homo antecessor, dated to around 850,000 years ago. In Africa, the picture was even more fragmented. We had isolated jawbones and crania, like the famous Kabwe skull from Zambia or the Bodo cranium from Ethiopia. These fossils hinted at a robust, large-brained species roaming the continent, but they floated in a chronological limbo. They lacked precise dates. Without firm dates, determining who was related to whom was largely speculative. Was the European Homo heidelbergensis the ancestor of us all? Or was there a distinct African lineage that gave rise to Homo sapiens? The muddle in the middle remained a puzzle, with half the pieces missing. This is where the Quarry discovery changes the game. These new fossils act as a revelation that clears the fog. By providing a secure anchor point at exactly 773,000 years ago, they demonstrate that a distinct hominin population was thriving in North Africa. This population retained ancient traits of Homo erectus, while foreshadowing the modern biology of Homo sapiens. It forces us to reconsider the geography of our origins. It suggests that the cradle of humanity was not a single GPS point in East Africa, but a continent-wide network of evolving populations, with the Maghreb playing a pivotal central role. Let's talk about the site itself, because Quarry is a geological treasure chest. Located just southwest of Casablanca, this quarry isn't a new blip on the radar. It has been a focal point of excavation since 1969. It is a massive cross-section of ancient time, cutting through the Oulad Hamida Formation. These are sequences of calcified dunes and marine deposits that document the rise and fall of sea levels over millions of years. Specifically, the fossils were found in the Grotte Hominides, or hominid cave. This was once a cave system carved into hardened dunes by a high-standing ocean. When the sea retreated, the cave filled with sands, collapsed roof blocks, and the debris of life. Now, here's a fascinating detail about the life in that cave. It was a carnivore's den. The bones found there, which include gazelles, zebras, antelopes, and yes, hominins, all bear the distinct gnaw marks of hyenas and porcupines. These predators dragged their prey into the dark recesses of the cave, unwittingly creating a fossil vault that would remain sealed for nearly 1,000,000 years. Among this debris, researchers recovered mandibles, isolated teeth, vertebrae, and a femur. These remains tell the story of a people who lived on the edge of the Atlantic, in an open woodland environment teeming with game, long before the Sahara became the arid barrier we know today. But the most revolutionary aspect of this study isn't just the bones themselves. It is the method used to date them. Dating fossils from the Middle Pleistocene is notoriously difficult. Radiocarbon dating, which everyone knows, only works back to about 50,000 years. Other methods, like uranium series dating on teeth, can be unreliable due to groundwater contamination. So how did they get such a precise date of 773,000 years? They used magnetostratigraphy. This is the science of reading Earth's magnetic history written in stone. You see, the Earth is essentially a giant magnet generated by the churning of molten iron in its outer core. But this magnet is not stable. At regular intervals throughout geological history, the Earth's magnetic poles have flipped. North becomes south, and south becomes north. These geomagnetic reversals are global events. They happen everywhere at once. When sediments, Like the sands filling the Thomas Quarry cave are deposited, they often contain tiny iron-rich minerals like magnetite. As these microscopic grains settle in calm water or wet sand, they act like tiny compass needles, aligning themselves with the Earth's magnetic field of that precise moment. When the sediment hardens into rock, that magnetic direction is locked in forever. It becomes a fossilized compass reading. The researchers, led by paleomagnetist Giovanni Muttoni and geologist David Lefebvre, took 180 separate samples from the stratified layers of the cave. They analyzed the magnetic orientation of each layer with painstaking precision. What they found was a perfect smoking gun. The lower layers of the cave sediments showed a reversed polarity, meaning the magnetic grains pointed south. This indicates they were deposited during the Matuyama Chron, a long period when Earth's magnetic field was opposite to what it is today. The upper layers, however, showed normal polarity, pointing north, corresponding to the Brunhes Chron, the current magnetic period we live in. Sandwiched exactly between these two zones was the Matuyama-Brunhes boundary. This is one of the most rigorously dated events in Earth's history. Through independent dating of lava flows and ice cores around the world, geologists have pinned the date of this reversal to exactly 773,000 years ago. The hominin fossils were found in Unit 4, a layer deposited immediately following this reversal. The magnetic signal was so sharp, and the sedimentation rate in the cave was so rapid, that the researchers could pin the age of the fossils to 773,000 years with a margin of error of just plus or minus 4,000 years. In the world of deep-time paleontology, where dates often come with error bars of 50,000 or 100,000 years, this is precision of an almost miraculous degree. The cave was, effectively, a magnetic time capsule sealed at the moment the poles flipped. So who were the people locked in this time capsule? The morphological analysis, led by renowned paleoanthropologist Jean-Jacques Hublin, reveals a fascinating biological mosaic. The fossils, particularly the mandibles, do not fit neatly into the simple boxes of Homo erectus or Homo sapiens. Instead, they show a blend of features that captures evolution in motion. They have archaic features. The jawbones are robust with a receding symphysis, which means they lack the protruding chin that is the hallmark of modern humans. Massive teeth and thick bone structure recall the ancient Homo erectus populations that had occupied Africa for over 1 million years. However, they also possess derived features. The shape of the dental arch and the details of the teeth show modernized traits that align them with later Middle Pleistocene hominins, the group often called Homo rhodesiensis in Africa. Crucially, these fossils bear a striking resemblance to the Homo antecessor fossils found in Atapuerca, Spain, which date to a similar period. This suggests a potential deep connection between the populations of North Africa and Southern Europe across the Strait of Gibraltar, or perhaps a common ancestral stock that expanded into both regions from a Central African source. The Thomas Quarry hominins likely represent a population very close to the last common ancestor of Homo sapiens and the Neanderthal Denisovan lineage. Genetic studies have long predicted that this split occurred somewhere between 550,000 and 765,000 years ago. This 773,000-year-old date of the Moroccan fossils places them right at the base of this divergence. They are the stock from which modern humans would eventually evolve in Africa, while their cousins who migrated to Eurasia would eventually become the Neanderthals. This discovery also forces a re-evaluation of the environment's role in human evolution. Today, we think of the Sahara Desert as a formidable barrier separating North Africa from the rest of the continent. However, the world of Thomas Quarry was vastly different. The analysis of the animal bones found alongside the hominins paints a picture of a green Sahara. We see primitive gazelles, antelopes, rhinos, and carnivores. During this period, North Africa was not an isolated island of habitability, but was connected to East and Sub-Saharan Africa by lush corridors of savanna and woodland. This connectivity is vital for understanding the evolution of our species. The Thomas Quarry population was not isolated. They were part of a pan-African gene flow. They shared technological traditions, specifically the Acheulean stone toolkit, characterized by large, teardrop-shaped hand axes, with populations as far away as Kenya and South Africa. The presence of these tools at Thomas Quarry confirms that the Maghreb was a thriving hub of technological innovation and habitation, not a backwater. The persistence of the Acheulean industry at Thomas Quarry over hundreds of thousands of years speaks to the cognitive stability and deep cultural roots of these people. The ability to shape a stone into a symmetrical pre-planned tool requires a level of foresight, planning, and manual dexterity that separates early humans from apes. For years, the dominant narrative of human evolution focused heavily on the East African Rift Valley, often called the East Side Story. Finds in Ethiopia, Kenya, and Tanzania were so numerous that East Africa was viewed as the sole engine of human evolution. But the Moroccan discoveries, first the 300,000-year-old Homo sapiens at Jebel Irhoud in 2017, and now these 773,000-year-old ancestors at Thomas Quarry, shift the center of gravity. These findings suggest that human evolution was a pan-African phenomenon. Innovations in biology and culture didn't just happen in one valley and spread out. They bubbled up in different regions that were periodically connected by climate shifts. North Africa, with its mild Mediterranean climate and rich coastal resources, may have been a crucial refugium where populations could thrive and evolve even when the interior of the continent dried out. The precise dating of the Thomas Quarry hominins allows researchers to synchronize the North African record with the global climate record. We now know that these humans lived during a specific interglacial, or warm, period, just after the magnetic reversal. This synchronization helps scientists model how ancient humans responded to climate change, expanding when the desert turned green, and retreating to coastal caves when the ice ages brought aridity. The success of the Thomas Quarry project is also a testament to the power of modern interdisciplinary science. It required the synthesis of paleoanthropology to identify the anatomy, paleomagnetism to unlock the magnetic code, geology to understand the stratigraphy, and paleoecology to reconstruct the environment. This collaboration, spanning Moroccan and French institutions, highlights the importance of revisiting old sites with new technologies. Thomas Quarry had been known for 50 years, but it took 21st-century magnetostratigraphy to fully unlock its secrets. In conclusion, the 773,000-year-old hominins of Casablanca stand as sentinels at the threshold of modern humanity. They lived in a world that was on the brink of profound change, both magnetically and biologically. The reversal of the Earth's poles that marked their time is a fitting metaphor for the evolutionary reversal that was about to happen, the transition from the archaic world of Homo erectus to the dawn of Homo sapiens. Because of the magnetic time capsule of Thomas Quarry I, these ancient Moroccans are no longer lost in the muddle. They have a time, a place, and a face. They remind us that our origins are not tied to a single garden in the East, but are rooted in the diverse, shifting landscapes of the entire African continent. As we look at their jawbones, robust, worn, yet undeniably akin to our own, we see the endurance of a lineage that survived ice ages, magnetic flips, and predators to eventually give rise to the storytellers of today. The cliffs of Casablanca have spoken, and their message is clear. The history of humanity is older, richer, and more interconnected than we ever dared to imagine. Thank you for listening to G Fun Facts Online, and stay curious.